and put all these numbers in. Probably they're still there if you are participating last time. All right? Let me just check and see if it's still there. Nope, I got a different one. All right. Give me a second. Get this in. Okay, anybody remember what happens next? Once we get the matrix put in, what happens? Do you remember? We are REF, that's right. So we go back in the matrix. So second matrix, over to math, and then down till you find our REF. And then second matrix, enter. And I got decimals. Did you get some decimals?
Yeah.
Okay, so let's math, track that, and this is what I came up with. Now, I put my matrix in really fast, so I don't know if I got it right or not.
Okay, so
Okay, that's what I came out with. What do you think? Does that look like what you came up with? Okay. Now, in the best case scenario, the matrix wouldn't look like this. In the best case scenario, it looks like this. When it looks like this, then the answer is X is 1, Y is 2, Z is 3, W is 4, or whatever the letters are. What is wrong with this result that we got?
there's no
There's no Z, whatever, that D, yeah, this is A, B, C. So this literally says 0D equals 0. This one would say D equals 4. 1D equals 4. This says 0 D's equals 0. What does that mean about D? Can it be anything?
Yeah.
Could it be 0? Yeah, but does it have to be 0? No, it could be 17. It could be the square root of 83. D could be anything. So we write that literally by saying D is something. D is something. Now, what does this row say? C plus 3/11 D equals negative 7/11. Remember, this is an equation. These are equations. So here's your A's and B's. We don't have any. 1C plus 3/11 D's equal, this is like the equals numbers here, equals negative 7/11. So what is C? Negative 7/11 minus 3/11 D. And I don't know what D is. So I'm done. I mean, I can't do anything else. All right, now you do this one. What does this row say? B plus 5 D's. That's B. There's no C's. 5 D's equal 5. So what does B equal? Okay, or, yeah, whatever order, doesn't matter. Order doesn't matter. And then finally, what does the top row say? A minus 38/11 D equals negative 3/11. Is everybody getting this where I got that from? So what does A equal then? Negative 3/11 plus 38/11 D. Just get A by itself, move that to the other side. And then do you happen to remember how we categorized all that?
No.
Okay, so here we go. We have A's, B's, C's, and D's. And each answer consists of two parts. If you look at A, it has a regular number and a D. So, regular number and a D. So there's A. Its number part is negative 3/11 and its D part is 38/11. All right, what's B? 5 and minus 5? What's C? And then D, don't let it be tricky.
311.
There's no number, but there's one D. Okay, one D. No number. That problem has infinitely many solutions. Because Michael could say, I'm gonna let D be 1, and then he could work them out. But Lenica might say, no, I want D to be negative 1. She could work it out. Everybody could pick a different number and everybody could give a different answer. That's the way we write it. Is that all right with everybody? All right, we'll practice that again. But now, we're moving on to 7-4. This is one of the coolest things ever. One of the coolest things ever. What we're getting ready to do. It is really amazing. All right, so here's the situation. We have a triangle, and we have vertices here. Now, if you prefer, you can actually plot those points, so set up a grid. If it bothers you to kind of have them randomly situated, you can actually graph them. It doesn't matter, it won't change anything, but it might make you feel better if this bothers you. How do we find the area of a triangle? 1/2 base times height. Now, could that be a lot of work for this problem? Well, first of all, I don't even have any of the lengths, so I'd have to do the distance formula to find the lengths. Then I'd have to drop an altitude in there because there's no height in that picture. I'd have to drop one in. Boy, that's a lot of work. Let me show you something. Pick an angle, I don't care which one. A. We are going to write the coordinates for the movement, we call it a vector, from A to B. Now, do not make this complicated. Pretend you're a little guy and you're walking from A to B. What is your X distance? If you're going from A to B, your X X distance is what?
Two.
2. And your Y distance is
3.
3. That's it, that's all you do. Okay, so you picked the angle A, so we said we're gonna go from A to B. Now we're gonna go from A to C. Okay, so same thing. 1 to -1, be careful. 1 to -1 would be -2, wouldn't it? -2? And then -1 to 7, 8. So we're simply describing the X movement from A to B and the Y movement from A to B, and then the same thing from A to C. If you picked angle B, then you would do BC and BA. Whatever angle you pick, you go out from that angle. Okay? Now, take these little vectors that you found and put them in a determinant. So 2, 3, -2, 8. So just like, don't move anything around, don't change anything, just put them in a determinant. Now evaluate that determinant. So some of you probably have to do this on your quiz. 16 minus -6.
So 22.
16 minus -6. Everybody okay with that? 22. The area of this triangle is 11. You're like, what? If we have time, I'll do it. I'll do it out longhand and show you. Or maybe I'll do that and
Divided by
put it in Canvas. But yeah, you take your determinant and divide it by 2. And that makes sense because every time you do area of a triangle, there's a half. 1/2 base times height, 1/2 side sine, semi-perimeter, half the perimeter if you're doing Hilo triangle. So there you go. Isn't that so cool? It is incredible. I wish I were these smart people that came up with this.
Why would you tell me that?
All right,
You're back.
everybody okay? All right, now, partial fraction decomposition. In your calculus class, there will be times when it will make the problem so much easier to look at it in its little component pieces rather than one big giant piece. So what I want you to think about is, does it make sense that this big fraction might have started out as 2 smaller fractions with these denominators? Now, I want you to think about that for a second.
Yeah.
Because if I were gonna add these, wouldn't I need a common denominator? And wouldn't the common denominator be those 2 pieces times each other? Right? So these are called the partial fractions. They're the little fractions that add together to give you the big fraction. Now, what do I not know? I know the denominators, but I don't know the numerators. All right? I multiplied this fraction by x plus 3 and this fraction by x minus 5, would my whole problem, all of it, that big huge mess, have the same denominator?
Yeah.
And I know that if the denominators are all the same, I can drop them. Right, think about that. If you have 3/4 plus x over 4 equals 1 over 4, doesn't that mean 3 plus x equals 1? Times by 4? Okay. So I'm gonna go ahead and write my new equation now with no denominator. So 5x minus 1 equals a times x plus 3 plus b times x minus 5. So far, so good? Well, let's distribute. Any ideas? No ideas? Well, this is an x, this is an x, and this is x. Does it make sense that 5 would have to equal a plus b? Because don't the x's on the right have to be equal to the x's on the left? And then what about the negative 1? What's the negative 1 going to equal? 3a minus 5b, that's exactly right. So, guys, to get from here to here, match up the like terms. So your x's on the left equal your x's on the right. Your numbers on the left equal your numbers on the right. Okay, now what?
Alright, substitute.
Exactly. So we're gonna either eliminate or substitute. You know I'm gonna eliminate because that's what I like the best. But you can do whatever you want. I'm gonna multiply this one by 5. Did you get A is 3 and B is 2? So what's my answer? What is my answer? Remember, our job was to find the partial fractions. What's this? So my answer is 3 over x minus 5, a over x minus 5, plus b2 over x plus 3. There are your partial fractions. There are the two fractions that if you add them together, you will end up with the original problem. Okay, I don't like that next note problem, so I'm gonna have you do something for me. I want you to get out the packet of review work that I gave you. You have a packet, it's got several pages to it. And we're just going to page 2. Yep, that's it right there. Yep. Yep. The very top page, it doesn't say reviewer or anything. It says period 5 is tops. Period 5 is tops. And we're going to page 2.
Also, two, five rocks.
It says period 5 is tops. But the one you're doing, page 2 says it box. All right, so page 2. We're gonna do 2 more examples of the 2 kinds of problems that we just did. All right, I got one in the notes. It's a little bit more complicated, we just don't have time. So we're gonna keep it kind of simple. All right, so we're on page 2. Problem number 1, A, says find the partial fraction decomposition for this thing. So first thing we do is figure out what our factors are. So -2 minus 1. And then we know we're going to have something over x minus 2 and something else over x minus 1. Are you okay? All right, everybody's busily writing. That's awesome. What are you doing? What are you doing now? What? Get a common denominator. And the common denominator will be both of the fractions. So this one needs an x minus 1. This one needs an x minus 2. Okay, now we have a common denominator. Okay, now what?
4x minus 5 equals ax minus.
Just the numerator. So 4x minus 5 equals ax minus a. I'm going to go ahead and distribute here. Plus bx minus 2b. All right. Now, what comes next?
4 equals a plus b.
4 equals a plus b. All of the x terms, everything with an x on the left equals everything with an x on the right. And similarly, -5 equals negative a minus 2b. Does everybody see where all that's coming from? Okay. Oh, these are ready to go. So -1 equals, did you get b equals 1?
Yeah.
And if b equals 1, then a must be 3. And then write your answer. What was the question? Find the partial fractions. So a 3 over x minus 2 plus 1 over x minus 1. That is your answer. Your answer is not a and b. Your answer is the fractions. Make sure when you write your answer that you put your a over your a denominator. So it's 3 over x minus 2 and 1 over x minus 1. Everybody good? Feel like you could do that if you had to?
Yeah.
All right, now let's look at the problem in the box. Same page, but the problem in the box. This is an area. So you've been given 3 ordered pairs. And your job is to find the area of the triangle. Okay. What is the first thing we have to do?
Take an angle.
Take an angle. Which one you want, Jimmy? A. Doesn't have to be A, but A is fine. Take an angle. Then go from A to B and from A to C. So whatever angle you picked, that's your starting point, and you go out from there. So describe the movement from A to B. 2 in the X direction, and 6 in the Y. And then A to C. A to C would be -2, 3. Good? Now what?
Oh, okay.
Make it
Determinant. So 2, 6, -2, 3. So again, we're not changing anything, we're just building a determinant. And then evaluating it. So 6 minus -12, you get 18? Divide by 2, so the area is 9. Now, one thing that could happen, it hasn't happened to us yet, but if you evaluate your determinants and it comes out negative, is that possible? Could this number come out negative? Yeah. If that happens, just drop the negative. Area has to be positive. And, for example, if I did AC first, this is what I would get. I'd get -18. So the area is still 9. If your determinant turns out negative, just drop the negative and make it positive. Okay? All right, back to the notes. Now we're going to do some review work. Do you remember early on in the year doing asymptotes and holes and all that?
Yeah.
All right, we're going to do it again. A little quicker because it's all review to you, but let's see what you remember. Tell me what you remember. If you say nothing, then it's bad. You don't need to say bad. This is in your notes.
You gotta factor first.
Anybody remember? This is number 3 in 7-4.
Draw a box. I know horizontal.
Okay, so Alden says, I remember something about this.
And it's gonna be 1. There.
That's 1, and that's an asymptote. What kind of asymptote?
Yeah.
Horizontal.
Horizontal.
That's a horizontal asymptote. So you have a horizontal asymptote at 1. And a way to remember that, Alden, might be x squared over x squared. That just is 1, right? So it says y equals 1. Y equals 1. Okay, perfect. All right, what else? Who remembers something else?
Factor.
Factor. So x plus 2, x minus 2, x plus 3, x minus 3. Everybody good with that? Now, sometimes when we do that, stuff cancels,
That'd be a hole.
and that's how you get a hole. Obviously, nothing's gonna cancel here, so there won't be any holes. That's fine, we just aren't any, okay? But what are there? What can I do with those things? Vertical asymptotes are
Negative 3 and 3.
at negative 3 and 3. So vertical asymptotes come from your denominator, because you know the denominator can't be 0. If you stuck a 3 in here, you get a 0 down there, and that's not good. You can't have that. Okay? Perfect. All right, anything else? Someone's yawning. I can't believe it.
What's the bottom one again?
The denominator gives me my vertical asymptotes. Anybody remember what the numerator gives me? 2 and negative 2 are special.
Y-intercept?
X-intercepts. Yep, they are X values, Harper. So they're gonna give me negative 2 and 2. And then you're right, I need the Y-intercept. How do I find the Y-intercept? I have to find it.
Plug in 0.
Plug in 0. So you can do that here, or you can do that in the beginning. I think it's easier in the beginning. If I put in 0, I get 4/9. That's all the biggies. Your asymptotes, your intercepts, and if you had them, your holes. Now you have to draw it. What do you think? What do you remember? So Colin says, I'm seeing a little parabola-like thing down here. Do you see that too? You got those 3 points kind of all lined up together. Guys, there's a chunk of picture on the left and there's a chunk of picture on the right. Any ideas about what those chunks look like? What, Harper?
I forget what they're called, but.
They?
Yeah.
That's exactly what they look like. Now, we talked about this back in the day, but on the ends of your rational functions, your fraction things you're graphing, you're always gonna have those kinds of shapes on the ends. Wacky stuff can happen in the middle, but on the ends. This can't be this, can't be that, because it's not allowed to cross the x-axis. So it has to be the one Harper told us it was. She was right.
So what's that?
You're graphing it.
That's all we're doing?
It's purple. And all the way to
Skips it.
So we're just doing the same stuff we did.
exactly. Yeah.
Easy peasy, lemon squeezy.
All right. All right, let's take a look at these. Anybody watching this video sees a kid right in the front row sound asleep.
I wasn't stupid.
It was.
I was
All right.
I was doing my work.
Congrats on engineer of the month.
Look,
Someone uses first points.
All right, here we go. Yeah, if somebody's watching that that's evaluating me, one of our big goals is student engagement.
I'm engaged.
All right, here we go. What do you think? I think we have to factor, Eli says. So, Royce, can you factor the top for me?
Sure, Royce. Which one was that?
The one we're on.
Two B numerous.
X plus
1. X plus 1, X plus 6.
No.
X plus 5.
Here we go. There we go. Now,
You're not done,
what about the denominator? Gotta take out a 2.
Royce.
And then I should be able to factor it, hopefully, So how does x squared minus x minus 2 factor? I pulled the 2 out of it. That would be x plus 1 minus 2. And now I'm super excited because
Is it point out on nothing or is it one or is it just zero? Both is denomination. Oh, we the whole.
all right, can everybody get to this point? We know that we're gonna have a hole in our picture. I'm gonna go ahead and do it so I don't forget about it. The hole is gonna be where x is -1, because that is the factor that canceled out. Right? How do I find the y? I need to plot that. Right in here, here. So if I put in -1, I'm gonna get 4 over -6. So -2/3. So I'll just put my little open dot there. Eli, the curve is gonna go through that point. So that's important, I get that in the right spot. All right, tell me what else I know. This is what you're now graphing, okay? So tell me what do I know about it?
Vertical.
A vertical asymptote at x equals 2.
I think the horizontal. Oh, it's one. No.
Where's the horizontal?
One of them.
1/2. Yep, the horizontal is at 1/2. Why is it at 1/2? Well, if you go back to the beginning, it's x squared over 2x squared. If you look at your reduced fraction, it's 1x over 2x, 1/2. Okay, what else do I have?
We've got X.
X-intercept at -5. X-intercepts come from the numerator. How do I find my y-intercept?
Plug in 0.
Plug in 0 for x, and I can do that in the beginning, or I can do it here. It doesn't matter, it'll do the same thing. If I put in 0, it looks like I get -5/4. And that's it. So, can I stack it? I think we've got this one pretty much figured out, right? No, I need to be up here, you're exactly right, because I can't cross the axis. So I have to be up there. Okay? Everybody good? All right. Here's what I want you to do right now with your partner. I want you to do C. And then I want somebody to come up and put it on the board for us. So we're doing C.
Basil.
And we sent back over senior mass. I got to choose all the songs for senior mass.
Really?
Hey, you guys are gonna send your guys, come on, I need this done and on the board. And we have 12 minutes to make that happen.
I think I'm right, but I don't want to.
No.
Huh?
Can I see it? That's yours. What'd you get? What are you doing? That's what I got. What was your, how'd you get the vertical? What was your one? The vertical? Or, yeah. Oh, I said, I subtracted 1 and divided 8. I think that's what we did. Oh, I reversed that. I reversed
Is that what you got?
Yeah, I didn't even see the answers.
Need somebody to put it on the board.
I don't know if I'm confident enough or not, yeah. You know what?
I think you're right.
My dad would never. That is not true. Literally not true at all. I paid for Coke and. Oh, it's because you didn't go to the hospital.
Hopefully, you got this done.
Sorry, no,
Oh, yeah.
What is Precal bringing tonight?
Answered one question this whole semester, you guys were all.
I've had 3 no air, 10 in an hour.
City's kind of not in.
that's crazy.
I thought birthday was.
You're coming to mountain.
Yeah.
So we appreciate you about it. You're coming mountain.
I started in mine twice.
They don't. City, you're
Right now it's 50 over 2 equals $100 racks.
Harper China Mountain. She's.
What?
Wait, that's not even right, is it?
That's showing it's almost 4 o'clock.
It'd be
I
111
know, I know where.
divided by.
You have it all right. You're one of us. You're one of us.
337, 338.
That is showing as 3. I think you're
I wish, right? It's like 30 seconds.
That's all we had in middle school. I still
It's not
get
that hard. You actually have the numbers.
But I
You
just,
actually have the numbers when you have.
I look at a watch.
Because they just done like 2 minus 1.
Yeah. Like, what is that?
Let's talk about this. Let's talk about this. We have a vertical asymptote at -1/8. I agree with that. I think that's perfect. We have a horizontal asymptote at 7/8. I believe that's absolutely perfect. We have an x-intercept at 2/7, and here's their work. So 7x minus 2 is 0, numerator is 0. So they solved that and got 2/7 comma 0, perfect. Then they plugged in 0, right here, and got -2, that looks absolutely stunning. Then they connected these two dots. The only thing I might say here is, that guy does not come curling back. He actually comes down and gets closer to the asymptote. Does that make sense? Yeah. And then up here, that's it, right there, that's it, perfect. Anybody have a question about that? All right, anybody have a question about the quiz I turned back? Some of them were magnificent,
Yes.
and some of them were in need of some stuff. Erica,
For mine, I had the one heart, it was question 7. I got confused with the factoring part.
one hard. Okay, so Erica's question is this. And by the way, several of you missed this problem. So pay attention. Erica, do I have the right problem? That's yours? So what did you do to start?
I eliminated the X.
Okay, so maybe multiply this one by -3.
Yeah.
So then the x's are gone. So then you have -y squared minus 6y equals -7. That's what you should have.
Well, yeah, I did do that.
Okay, and that is a quadratic, which you have to get set equal to 0. Now, I have this issue where I don't like that to be negative. So I'm gonna move everything over to the other side. So I'm gonna add y squared, add 6y. So I have this. So instead of adding 7 here, I move everything that way. Now, that factors. And my answers then have y coordinates of
3 exclamations.
1 and -7. And then I can come back over here. And I have to find my x. So if I put in 1, it looks like my x is 2. And if I put in -7, it looks like my x is 8. Mhm. Anybody else have a question about that? Okay, so tomorrow, we're going to do a practice quiz, and then on Friday, we'll take another quiz. And then we'll be done with quizzes, and then we'll have a chapter.
The last one ever. Oh.
That's for the chapter. By the way, 7-4, homework is due Thursday. 7-4 is due
173
Thursday.
today, probably.